All right, you are welcome again. Today, let's consider how to find the inverse of a matrix using elementary row operation. Previously we talked about inverse of a matrix, and then we listed three ways or three methods that one can use to find the inverse of a matrix. And we have considered using determinant method, but today we are going to consider using elementary row operation. Okay, now let's go. We'll say let A be an n by n non-singular matrix and I an n by n identity matrix. Then the steps include: number one, we are going to form a monster matrix, n by 2n matrix. That is, you have your A, then you can use dot or you can use a line to demarcate your identity matrix. But this is one matrix, we call it monster matrix. So after forming your monster matrix, step 2, we are going to perform elementary row operation on this matrix and to reduce it to form IB. That is what we want to do is this. We have a matrix A in this side and then identity matrix in this side. So we are going to perform elementary row operation that this A will turn to identity, and then this side, that is identity, will turn to another form of matrix. So that form of matrix, let's call it A, is automatically the inverse of matrix. Hello, that is, now let me show you what we are trying to say, or what we are trying to do. We have a matrix like this, A, and then a line demarcating identity. So we're going to perform operation on this matrix such that this A will turn to identity, and then the identity will turn to another matrix. So this matrix that we obtain as a result of turning matrix A to identity is called the inverse of the matrix. Let's take a look at this example. Given matrix A 4 3 2 2, this is 2 by 2 matrix, all right? And then it says find the inverse of matrix A using row operation. You get it, right? Using elementary row operation. Now let's go. The first thing, or the first step we're going to take, is that we are going to form the monster 2 by 4 matrix M. That is, we're going to have matrix like this, A by this side, and then identity matrix by this side. Then we're going to perform the row operation. Okay, now let's go. Let's form it. We have M, which is monster matrix. So here we have our first matrix, which is 4 3 2 2. Then we have a line, and then we have identity matrix 2 by 2. That is 1 0 0 1. Okay, good. Now from this place, we have formed a monster matrix. So when you look at this matrix that we have 4 3 2 2, and then beside it we have 1 0 0 1. So we want to transform, we want to change this real matrix, which is 4 3 2 2, to become an identity matrix, and then the other side is going to come out with some values. Sure you get, right? Now, when you compare these two matrices, the monster, the identity, and the main matrix, we have 4. And then in the other side, that same position, that is row 1 column 1, is having 1, right? Okay, now look at it. So here now, the first row, first column, we have 4. Hello, we have what? 4. And then we are interested in making this 4 3 2 2 identity matrix. And how does identity matrix look like? We have 1 0 0 1. All right, so this 4 here, we want to make it to be 1. Why? Because in identity matrix, in the first row and the first column, the element there is 1. So that's why we want to make 4 to be 1. So what can we do? The question is, what can we do to this 4 so that it will become 1? What kind of operation can we perform on this 4, number 4, so that it will become 1? So now, we are going to say, if you multiply this 4 by the inverse, I think it's going to give you 1. Now, when you multiply 4 by the inverse, which is 1 all over 4, it is going to give you 1. So, in this elementary row operation, whatsoever you do to one element, do also to the rest. We're going to say that as you multiply 4 by the inverse 1 all over 4, it becomes 1. We are also going to multiply the rest of the elements by this same 1 all over 4. We don't care to know what the outcome will be, but we have succeeded in what we want to do. So that means we are going to say, we are going to replace R1 with 1 all over 4 R1. That is, we are going to multiply R1 by 1 all over 4 and then replace it with your new values. Okay, now let's go. If you multiply 4 by 1 all over 4, it's going to give you 4 all over 4. 4 all over 4 is equal to what? 1. And then when you multiply 3 by 1 all over 4, it's going to give you 3 all over 4. And then when you multiply 1 by 1 all over 4, it's going to give you 1 all over 4. And then when you multiply 0 by 1 all over 4, it's going to give you 1 all over 4. So we have performed this on the rows. Hello, we have performed this on the what? On the rows. That is the row 1. So this same thing that we did, we performed the operation on row 1. So that is the reason why it is called row operation. If the same thing we follow it on column, that is, we perform the operation on columns, that is where we call it elementary column operation. But this is on rows, so we call it row operation. Now let's go again down to this 1. That is second row first column. Second row first column. We have the number 2. And then for us to form the identity matrix, under 1 we should have 0. So we're going to ask ourselves a question: what can we do to this 2 so that it will become 0? What can we do to this 2 so that it will become 0? Please pay attention. We want to make this 2 to be 0. So how can we do it? And then we say the number above, that is row 1 column 1, is 1. And then if we say, let's multiply this 1 above by the same element that we are having, that we want to make to be 0. If we multiply that 1 by that number, which is 2, it's going to give us 2. And then we'll say this same element that we want to make it to be 0. When we say this same element minus the element that we just multiply by 2 now, it's going to give you 2 minus 2, which is equal to what? 0, which is exactly what we want. So now we are going to put it in a statement and say, for us to achieve this same thing here, we are going to say, let us replace row 2 with row 2 minus 2 row 1. We replace row 2 with row 2 minus 2 row 1, because we multiply the first row, the first element there by 2. Why? Because we want to make this pivot element to be 0. So, and whatsoever operation you perform on a pivot element, you make sure you perform it to the rest. So we say the entire row 2 should be replaced with row 2 minus 2 multiplied by row 1. Now let's go. When you multiply row 1 by 2, then subtract it from row 2. That is what we want to do. Now let's go. We have row 1, we have 1, right? Now multiply by 2 is going to give you 2. Then 2 minus 2, we have 0. And then to the next element, that is row 2 column 2, we have 2 there also. Now when you multiply 3 all over 4 by 2, what is it going to give you? It's going to give you 6 all over 4. And then when you say 2 minus 6 all over 4, it's going to give you 1 all over 2. You get it, right? Good. And then let's go to the next one. We have 1 all over 4 in row 1. Now when you multiply 1 all over 4 by 2, it's going to give you 2 all over 4, which is the same thing as say 1 all over 2. And 0 minus 1 all over 2 is going to give you minus 1 all over 2. And then the next one we have 0. 0 multiplied by 2 is 0. 1 minus 0 is 1. So we have performed a row operation on the first row and then the second row. So in the first column now, we have 1, 0. Now if you look at the real identity matrix that we are having 1, 0, 0, 1. We have completed the first column. So going to the second column for us to have the complete identity matrix. Let's see what we are going to do. Now going to the second column, we have the other side to be identity matrix. And then in the last column, the last row, we have 1 there, right? And then in that same position, we are having 1 all over 2. You see this 1 all over 2, right? So we want to make this 1 all over 2 to be 1. So what are we going to do? So we can simply say, let's multiply this 1 all over 2 by the inverse. So what is the inverse of 1 all over 2? The inverse of 1 all over 2 is 2. So let's multiply 1 all over 2 by 2. Thereby, we're going to have 1. Do you get it? Now, whatsoever you do to this, you also do to the rest of the elements. Now let's go. Here, we are going to put it in a statement and say, we are going to replace the entire row 2 with 2 multiplied by row 2. We are going to replace row 2 with 2 multiplied by row 2. So that means we are going to multiply the entire row 2 by 2. You get it, right? Now let's go. Let's do it. So in the row 2, when you multiply 0 by 2 is 0. And then multiply 1 all over 2 by 2 is going to give you 2 all over 2, which is equal to 1. Then multiply minus 1 all over 2 by 2 is going to give you minus 2 all over 2, which is equal to minus 1. Now we have 1 there, right? Multiply 1 by 2 is going to give you 2. All right? Yes, you can see how our matrix look like now, right? We are going gradually to form an identity matrix in this first side. So we have succeeded in getting 1, succeeded in getting 0, and succeeded in getting 1 again. Okay, now let's go remaining the last part, which is 3 all over 4. So this 3 all over 4, we want to make it to be 0. This 3 all over 4, we want to make it to be 0. What can we do? Now, so here we have 3 all over 4. So we're going to multiply this 1 under it by 3 all over 4. And then subtract it from the 3 all over 4. Thereby, you're going to have 0. Okay? So whatsoever you do to this, to one element, you also do to the rest of them. Now, we are going to put it in a statement like this. We are going to say row 1 should be replaced with row 1 minus 3 all over 4 multiplied by row 2. That is, you are going to multiply the entire row 2 by 3 all over 4 and then subtract it from row 1. If you do it, the pivot element that we are interested in making 0 is going to be 0. And then whatsoever that happened to the rest of the elements is none of our business. You get it, right? Now let's go. The first element in the second column, we have 0. So 0 multiplied by 3 all over 4 is going to give you 0. And then the row 1, the number above, which is 1, minus this row 2 now that we multiply by 3 all over 2 is going to give us 0. All right? Yes. Now let's go again. The next element, we have 1. So 1 multiplied by 3 all over 4 is going to give you 3 all over 4. Now row 1 minus this row 2 times 3 all over 4. So that means we're going to have 3 all over 4 minus 3 all over 4, which is equal to 0. Okay, yes. Now let's go again. We have minus 1. So let's multiply minus 1 by 3 all over 4. So we're going to have minus 3 all over 4. Okay, yes. Now, if we say 1 all over 4 minus 3 all over 4, we are going to have 1 all over 4 plus 3 all over 4. So 1 all over 4 plus 3 all over 4 is going to give you 4 all over 4, which is equal to 1. So in the position, we will have 1. Okay, and then let's go the last one. We have 2. Okay, so we multiply this 2 by 3 all over 4. So we're going to have 6 all over 4. And then row 1 now, which is 0 minus 6 all over 4. So it's going to give you minus 3 all over 4. All right. Yes, we have performed this operation. And then we found out that our monster matrix 1 we have is equal to 1, 0, 0, 1. And then we have 1 minus 3 all over 2 minus 1, 2. So automatically, the main matrix that we have, which is 4, 3, 2, 2, have changed to what? Identity matrix. And then the identity matrix have changed to another matrix entirely. So that matrix itself that we got, this new matrix that we just obtained now, is called the inverse of the matrix A that is being given to us. All right? Yes. The second example says, given matrix A is equal to 2, 0 minus 2, 1, 4, 2, 3 minus 1, 1. And then this is 3 by 3 matrix. 3 by 3 matrix. The question is, find the inverse of this matrix using elementary row operation. We are asked to find the inverse of this matrix using elementary row operation. Now let's go. The first thing we're going to do, we're going to form the monster matrix. So now let's have our main matrix. Then let's draw a line. And then beside it, we are going to form 3 by 3 identity matrix. So to form 3 by 3 identity matrix, we're going to say 1, 0, 0, 0, 1, 0, 0, 0, 1. All right. 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called identity matrix. So as we combine these together, it is called monster matrix. Okay. Now let's go. You know, we are interested in making this our main matrix to turn to identity matrix. So the first thing is this. We're going to ask ourselves a question. What can we do to this number here, which is 2, to turn to 1? So the best thing is you are going to multiply this 2 by the inverse. So the inverse of 2 is 1 all over 2. So let's multiply this 2 by the inverse 1 all over 2. Is going to give us 2 all over 2. 2 all over 2 is equal to 1. So automatically, this pivot element 2 has turned to 1. And then whatsoever we do to this one element, we do also to the rest of the elements. So now let's consider the rows. So we're going to perform this operation on the rows. So the next element is what? 0. So 0 multiplied by 1 all over 2 is 0. And then the next element is minus 2. So minus 2 multiplied by 1 all over 2 is minus 2 all over 2. Minus 2 all over 2 is equal to minus 1. Now let's also go to the next one, the identity now. We have 1. 1 multiplied by 1 all over 2 is equal to 1 all over 2. So the next one we have 0. 0 multiplied by 1 all over 2, 0. And then the next element, the last, we have 0 multiplied by 1 all over 2, which is equal to 0. You get it right? Good. We have succeeded in making the first element to be 1 as it's supposed to. Now let's move under it. Under it we have 1 also, right? Yes, we are interested in making this 1 to be 0. We are interested in making this 1 to be 0. So what are we going to do? So if you say this 1 minus the 1 above, I think going to give you 0. Is that true? Yes. So whatsoever you do to this one will also do to the rest of the element. So putting it in a statement, we are going to say, let us replace row 2 with row 2 minus row 1. Because when you say 1 minus 1, which is 1 in row 2 minus 1 in row 1, it's going to give you 0. And that is exactly what we are looking for, okay? So mathematically, or in statement, we can say replace row 2 with row 2 minus row 1. Let's do it. So here we have row 2 to be 142,001, right? So let's replace it with this same row 2 minus row 1. Now, when you say 1 minus 1 above, it's going to give you 0. And then the next element, we have 4. So this 4 minus 0 above is going to give you 4. Now, let's go to the next one. We have 2. 2 minus 1, which is we're going to have 2 plus 1, which is equal to 3. And then the next one, we have 0 minus 1 all over 2, which is equal to minus 1 all over 2. And then we have 1 minus 0, which is equal to 1. And then we have 0 minus 0, which is equal to 0. We have performed this operation on row 2. Now let's go. We are going to consider the next one. We have succeeded in making 2 to be 1, 1 to be 0. All right. Now let's go again. Let's consider the next element, which is 3. That means we are going down the column. Okay. So the first one will have 1, the second one will have 0, then the third one will have 3. So we want to make this 3 to be 0. So we want to make this 3 to be 0. What are we going to do? So now pay attention. You know, the element in the first row, first column, which is 1. So what if we say this 1 now multiply by 3? It's going to give you 3. And then you say this 3 minus the 3 above is going to give you 0. All right? That is to say, you multiply row 1 by 3 and then subtracted it from row 3. So automatically, the pivot element in row 3 is going to give you 0. Now let's see it. In statement, you are going to say, let us replace row 3 with row 3 minus 3 times row 1. We are going to replace row 3 with row 3 minus 3 times row 1. Let's go. We have our row 1 to be 1, 0 minus 1, 1 all over 2, 0, 0. Okay, good. Let's multiply the row 1 by 3. So we're going to have the first one, we're going to have 3. So this 3 now, subtract it from row 3. We're going to have 3 minus 3, which is equal to 0. Okay, now let's go to the next element. Still on row. The next element is 0. Let's multiply this 0 by 3. We're going to have 3 times 0, which is equal to 0. So this 0 subtracted from row 3. That means we're going to have minus 1 minus 0, which is the same as minus 1. And also in row 1, the next element in row 1, we have minus 1. So minus 1 times 3 is going to give you minus 3. Now this minus 3 should be subtracted from row 3. And then the element under it is 1. So we're going to have 1 minus minus 3. So we're going to have 1 plus 3. So 1 plus 3 is equal to 4. All right? So we write it 4. Then the next one in the identity matrix now, we have 1 all over 2. So 1 all over 2 multiplied by 3 is going to give us 3 all over 2. Then this 3 all over 2 should be subtracted from row 3. And then the element in row 3 under this 1 all over 2 is 0. So we're going to say 0 minus 3 all over 2, which is equal to minus 3 all over 2. Then the next element still in row 1 is 0. So 0 multiplied by 3 is what? 0. Then 0 minus 0 is equal to 0. Then the next one is 0. So 0 multiplied by 3 is what? 0. And then 1 minus 0 is equal to 1. So we have performed the operation in row 3. And then we came out with 0 minus 1, 4, minus 3 all over 2, 0, 1. Alright? Yes, you can see how gradually that we are forming an identity matrix in our main matrix. Alright? Yes. Let's go again. Second row, second column. Second row, second column. The pivot element 4. We want to make it to be 1. What can we do? So we're going to multiply this 4 by the inverse of 4, which is 1 all over 4. Automatically going to give us 1. So whatever we do to this element, we also extend it to the rest of the elements. So the first element in row 2 is what? 0. So 0 multiplied by 1 all over 4 is 0. So we write it that way. And then we have the next element, which is 4. So 4 multiplied by 1 all over 4 is equal to 4 all over 4. 4 all over 4 is equal to 1. Alright, so the next element. So the next element is 3. So 3 multiplied by 1 all over 4 is going to give you 3 all over 4. Alright, yes, also the next element. So we have minus 1 all over 2. So minus 1 all over 2 multiplied by 1 all over 4 is going to give you minus 1 all over 8. Okay, yes, then the next element is 1. So 1 multiplied by 1 all over 4 is equal to 1 all over 4. And then the next element is 0. 0 multiplied by 1 all over 4 is equal to 0. Alright, yes. We have also performed this operation in row 2, where we say, let's replace row 2 with 1 all over 4 row 2. That is, you multiply row 2 by 1 all over 4 and then replace it with the row 2 that we are having. Okay, yes. Now look at it carefully. Look at what we are having now. We have 0, 1, 3 all over 4, minus 1 all over 8, 1 all over 4, and 0. Okay, now let's go again. In row 3, the number under this one that we just worked on now, the number there is minus 1. So we want to make this minus 1 to be 0. We want to make this minus 1 to be 0. Alright, so what are we going to do? So what if we say this minus 1 plus 1 above, and then the above is row 2. So when you say minus 1 plus 1, it's going to give you what? 0. So whatever you do to this element, you do also to the rest. Now, in statement, you are going to say that we are going to replace row 3 with row 3 plus row 2. Because we say minus 1, which is row 3, plus 1, which is in row 2. So that's why we say we're going to replace row 3 with row 3 plus 2. So when we perform this operation, we're going to have our desired result. So now, in row 3, we have the first element, 0. So 0 plus the first number in row 2. So that means here we have 0 plus 0 equal to 0. Okay, and then to the pivot element, the main element now, we have minus 1 plus 1, which is equal to 0. Also, we have 4 in row 3. The next number in row 3, we have 4. So 4 plus 3 all over 4. 4 plus 3 all over 4 is going to give you 19 all over 4. It's going to give you 19 all over 4. Is that clear? Yes. Now, the next one, we have minus 3 all over 2 plus, then we have minus 1 all over 8. So that means going to say minus 3 all over 2 minus 1 all over 8. So when you perform this operation, you are going to have minus 13 all over 8. Minus 13 all over 8. Alright, the next number in row 3 is 0. So we're going to say this number plus the number in row 2, which is 1 all over 4. So 0 plus 1 all over 4 is going to give you 1 all over 4. Alright? Yes. The last element still in row 3 is 1. And then this one multiplied by the element in row 2, which is 0. So we have 1 plus 0, which is equal to 1. So we have succeeded in making third row second column element to be 0. Okay? Alright, let's go again. In the main matrix that we have 19 all over 4. And then in the identity matrix, we have 1 there, right? So we want to make this 19 all over 4 to be 1. I want to make this 19 all over 4 to be 1. So what are we going to do? So if you multiply this 19 all over 4 by the inverse, which is 4 all over 19, is going to give you 1, right? So whatsoever you do to this, you're going to do same to the rest of the elements in the same row. So in the statement, we are going to say replace row 3 with 4 all over 19 multiplied by row 3. You get it, right? We're going to replace row 3 with 4 all over 19 multiplied by row 3. So in the first element in row 3, we have 0. So 0 multiplied by 4 all over 19 is equal to 0. The next element still in row 3, we have 0. 0 multiplied by 4 all over 19 is still equal to 0. So the next element, which is 19 all over 4. So 19 all over 4 multiplied by 4 all over 19 is equal to 1. So the next element is minus 13 all over 8. So minus 13 all over 8 multiplied by 4 all over 19 is going to give you minus 13 all over 38. Okay, so now let's go. The next element is 1 all over 4. So 1 all over 4 multiplied by 4 all over 19 is going to give you 1 all over 19. All right, yes, the next element is 1. So 1 multiplied by 4 all over 19 is equal to 4 all over 19. All right, yes, we have succeeded in making some few elements to look exactly as identity element, remaining 2. Okay, now let's go again to row 1. Let's go to row 1. Here we have minus 1, right? In row 1 column 3, row 1 column 3, we have minus 1. So this minus 1, we want to make it to be 0. What are we going to do? So if you say this minus 1 plus the element 1 in row 3 is going to give you 0. It's going to give you what? 0. So when you say minus 1 in row 1 plus 1 in row 3, it's going to give you 0. So in a statement, we are going to say replace row 1 with row 1 plus row 3. So we're going to say in the statement, replace row 1 with row 1 plus row 3. So here, now let's go. In row 1, the first element there is what? 1. So 1 plus 0 in row 3 is equal to 1. The next one is 0 in row 1. So row 1 plus 0 in row 3 is equal to 0. So the next one we have minus 1. So minus 1 in row 1 plus 1 in row 3 is equal to 0. Now let's go again. The next one we have 1 all over 2 in row 1. So 1 all over 2 in row 1 plus minus 13 all over 38 in row 3. What's it going to give us? It's going to give us 3 all over 19. You get it, right? Good. Now let's go again. The next element is 0. So 0 plus 1 all over 19 in row 3 is going to give you 1 all over 19. The next one we have 0. So 0 in row 1 plus 4 all over 19 in row 3 is going to give you 4 all over 19. So now the first row, that is row 1, we are having 1 0 0, 3 all over 19, 1 all over 19, 4 all over 19, and then the rest remains unchanged. Okay, now if you look at it very well, we have almost gotten our identity matrix in our main matrix. Here we have 1 0 0, we have 0 1, 3 all over 4, and then we have 0 0 1, remaining the row 2 element, which is 3 all over 4. We want to make it to be 0. Then we have formed our identity matrix. So how can we make this 3 all over 4 to be 0? That is the question. How can we make this 3 all over 4 to be 0? So we are going to say, if you pick this 3 all over 4 and multiply by row 3, which is 1, is going to give you 3 all over 4. Then subtract it from row 2. This same 3 all over 4. So when you say 3 all over 4 minus 3 all over 4 is going to give you 0. So what you do to this, you also do to the rest of the elements. So that means in statement, we are going to say, let us replace row 2 with row 2 minus 3 all over 4 row 3. Okay, now let's go. Let me show you what I'm trying to say. So in row 2 now, we have 0, 1, 3 all over 4, minus 1 all over 8, 1 all over 4, and 0. Okay, so we're going to multiply row 3 by 3 all over 4, and then subtract it from row 2. So row 3 now, the first element is what? 0. So 0 multiplied by 3 all over 4 is 0. So subtract this 0 from the element in row 2, which is 0. 0 minus 0 is 0. Now do so to the next element, is also going to give us 1. Okay, that is when you say 0 multiplied by 3 all over 4 is equal to 0. And then subtract 0 from 1 is equal to 1. Okay, now the next one, we have in row 3, we have 1. So 1 multiplied by 3 all over 4 is equal to 3 all over 4. Now subtracting 3 all over 4 from the element in row 2, which is 3 all over 4. So we have 3 all over 4 minus 3 all over 4, which is equal to 0. All right, moving to the next side, we have in row 3, we have minus 13 all over 38. So when you say minus 13 all over 38 multiplied by 3 all over 4, what are we going to have? We are going to have 39 all over 52. All right, so this 39 all over 52 to be subtracted from row 2. So when you say minus 1 all over 8 plus 39 all over 52 is going to give you 5 all over 38. All right, good. Then the next one, we have 1 all over 19 in row 3. So this 1 all over 19 in row 3 multiplied by 3 all over 4 is going to give you 4 all over 76. So this 4 all over 76 to be subtracted from row 2. And then the number in row 2, the element in row 2 is 1 all over 4. So we're going to say 1 all over 4 minus 4 all over 76. So 1 all over 4 minus 4 all over 76 is equal to 4 all over 19. All right, yes. So we're going to write 4 all over 19. Now the next one, we have 4 all over 19, the next element. So when you say in the third row, 4 all over 19. So when you say 4 all over 19 multiply by 3 all over 4 is going to give you 3 all over 19. All right, so this 3 all over 19 in row 3 should be subtracted from row 2, and then the element in row 2 is 0. So when you say 0 minus 3 all over 19 is going to give you minus 3 all over 19. So the second row now is having 0, 1, 0, 5 all over 38, 4 all over 19, and minus 3 all over 19. So we have succeeded in transforming this matrix to identity matrix. So the identity matrix that was previously on the right hand side is now on the left hand side. So we have 1 0 0 0 1 0 0 0 1, and then in our right hand side now we have 3 all over 19, 1 all over 19, 4 all over 19, that is row 1. The row 2 now, we have 5 all over 38, 4 all over 19, minus 3 all over 19. The last row, we have minus 3 all over 38, 1 all over 19, and 4 all over 19. All right, yes, this matrix that we have in our right hand side now is called the inverse of the matrix A that was given to us. All right, yes, thank you very much for watching.